Here we go. Today is January 4th, 2020. If you didn't know the date, there's the date. Here's the title of the notes today. Exponential form. Okay, wait a second. I don't think you guys heard me. I actually counted down even. Like I said, we're getting started in 5, 4, 3, 2, 1. We already did that. So we're talking about exponential form today. And we're going to be talking about radical form today. And I'm going to forewarn you guys. This is kind of exciting, actually. It's not really a forewarning. A forewarning would mean that something ominous is about to happen. That means not very good. But this is exciting because we're about to do a mathematical concept today that nobody in this class has ever done before in their lives. So this is like a first time for everybody that what we're about to do in class. You guys will never forget this. This will be like your first kiss. You know? Or or the first time you go to Disneyland and you see Mickey Mouse. Or whatever it is. Okay. First of all, now you guys, don't mistake the fact that I say what we're going to do is brand new and nobody's ever seen it to mean that it's difficult, because it's not difficult. So what we're going to do is you're going to do some brand new kind of math that you've never done before, but on a scale from 1 to 10 of difficulty, from 10 with 10 being like incredibly difficult, I would put today at about a 2.5 to a 3. Okay? So it's going to be new. So if you're not paying attention, you're going to have no prior knowledge to draw from to try to pull this out. Okay? Because it's going to be brand new. But it's not super difficult, which means we should pick it up pretty quickly. Now, this first part here is review. I just need to review some terminology. So we're going to talk about problems in exponential form. An exponential form is any problem that has an exponent. Like that. Any expression that has an exponent in it is exponential form. Okay? Where in this case the 1/2 is considered the exponent. And then what's the thing below the exponent called? The base. Okay? So everything in exponential form will always have an exponent and will always have a base. And we've learned in the past week and a half, the exponent could be any kind of number. Positive, negative, fractions, it could even be 0. Okay, but this is what we talk about in exponential form. You're going to be looking at problems, expressions in exponential form. And then we also have problems or expressions in what we call radical form. Okay? An expression is in radical form if you see this symbol. That symbol. Some of you guys call that the square root symbol.
That's the radical.
Yeah, but actually the technical name for that is the radical symbol. Okay? So this symbol right here is what is known as the radical symbol. And there's a reason why you call it a square root. But it's not always called the square root. It depends on a certain item in the expression. But if you see this symbol, that means you're in radical form. Okay? Pretty easy. If you see this symbol, you're in radical form. If you see an exponent, you're in exponential form. Everybody understand that so far?
Yes.
That's pretty easy. Okay, but let's talk about radical form for a second. And somebody's going to remember this. Somebody's going to remember what I'm about to ask you. Let's say I put a 9 right there. And let's say I put a 3 right there. In this radical formed expression, the 9 is called the what?
Index.
Somebody said it earlier. What's the 9 called?
The radicand.
The radicand. So, whatever is inside the radical symbol is called the radicand. And it's a weird word. It's so weird that I can't even say it. R-A-D-I-C-A-N-D. Radicand. On August 26th of last semester, we talked about this. You can look it up in your notes if you don't believe me. But we did talk about a radicand. And does anybody remember what the name is for that little number 3? In the pocket? No. It's called the index. That little number right there is called the index. Okay, and you guys, that little number is always written really, really small. Like I wrote it here. It's not written normal size. Okay, now, let's review. What's that symbol called?
Radical.
That's called the radical symbol. No matter what I put inside the radical symbol, say I put a 15x in parentheses and to the third power. No matter what I put inside the radical symbol, what's it called? All the stuff inside the radical symbol. Yeah, the radicand. All of this stuff right here is what is known as the radicand. Okay? So you guys, if I said, hey, what's the radicand for this expression? You would say parentheses 15x, close the parentheses to the third power. Okay? Now, somebody's going to get this right. I can feel it in my soul. What's the index? It's not a 1. Emily.
It's a 2.
It's the number outside of
Well, yeah.
radical symbol.
It's the number right there, but if there's no number there, what is it?
2.
It's a 2. Okay? The index is a 2 if you don't see an index. Okay? You guys? I'll say that again. The index is a 2 if you don't see an index. Can I get an amen? Amen. Yes. Okay? Excellent. Now, Michael, that is a great question. Hey, Michael, not this Michael, but another Michael. He asked, do you write the 2 or do you don't write the 2?
Don't write.
Here's the thing. You don't write it. Okay? Any math book above 7th grade would never put a 2 for the index. They always leave it blank. Okay? So expect to never see a 2 there. You might see a 3, you might see a 4, you might see a 5, but you're never going to see a 2. You just have to know it's a 2. No, you'll never see a 1. That's a great point. The index has to be 2 or higher. You'll never see a 1 for the index. It has to be 2 or higher, but will you ever see 2? No. Okay? So we've got that right there. All right, now, everything below this green line is brand new. Hang on to your seats because this is where it gets brand new. It's not hard. It's not difficult, but you've never done this before in your lives. Carla, you ready? Heck yeah. Okay, so let's say I have 8 to the 1/3 power. Okay? You guys, what type of form is that in? Exponential or radical?
Exponential.
That's obviously an exponential form. Here's what you guys have to know how to do today. You have to know how to turn this into a radical form problem. A radical expression. Now you guys, it's very easy and it follows a pattern. Draw the radical symbol. Here's how you do it. Draw the radical symbol. Take the base, which is what? 8. Make it the radicand. Take the denominator, which is what? No, the denominator. 3. Make it the index. Take the 1, which is the numerator, and make it the exponent for the radicand. So your radicand would be 8 to the 1 power, and you would have an index of 3. Okay, you guys? So check it out. 8 to the 1/3 power is the exact same thing as the way we would say this is the cube root of 8. Now, do you guys think I should write this 1, or is that unnecessary to write the 1?
Unnecessary.
That is unnecessary. So actually, the appropriate way to write this is index of 3, radicand of 8. You don't write the 1 exponent, even though it's there. Okay? I'm going to give you guys a second. Does everybody see the pattern?
Yeah.
You guys, do you see the pattern where the numbers went?
Yes, Mr. Trutna.
It's a pattern.
Yeah.
We're going to practice it. We're going to practice it 5 times. 4 more. We've already done 1. After, hey, ladies and gentlemen, after 3 times, most of you are going to be thinking to yourself, Mr. Trutna, I understand the pattern. Do we have to keep going? The answer is yes. We have to keep going for 2 more times. Okay, we're going to do 5 of these. Next one, 27 to the 1/4 power. I want to turn this into radical form. So I draw the radical. What's the index? 4.
Yes, sir.
What do I put inside for the radicand? 27, and do I have to put to the 1 power? No. So you guys, the radical with an index of 4 of 27 is the same thing as 27 to the 1/4 power. These two are the exact same expression. They're the same thing. Okay? Let's keep going. How about x to the 2/7 power? Can you guys put it in radical form?
Yes.
What's the index? 7. What would you put inside for the radicand?
X to the 2.
X to the 2nd power. Okay?
Put it back one more time.
So far, so good. Yes or no?
Yes, sir.
Okay, we're rolling. Now, guess what? You have to know how to do it the other way.
Put it back into X.
So you have to know if I give it to you in radical form, you have to know how to give it to me in exponential form.
Yes, sir.
All right? So what would the 4th index of 8 to the 3rd power be in exponential form? What, Nicole? 8 to the 3/4 power. Okay? This would be 8 to the 3/4 power. Follow the pattern. Last one. I said we're going to do 5 of these, and then we're going to start actually doing some computational type math. Okay, this one, I don't know why. I think it's because people weren't paying attention. This one has messed people up all day, and you're my 5th go around on this, so hopefully we can get it. So I have that, which by the way is not showing an index. We've already talked about that, so what's the index? 2. And the 5's not showing an exponent, so it's a 1. So what would this be in exponential form? 5 to the 1/2 power. This would become 5 to the 1/2 power. Okay? You guys getting the idea, yes or no?
Yes, sir.
All right, moving on. My next page. Okay. You guys, do not talk amongst yourselves yet. Do not write this down, though. Tell me what, don't write this down, what the answer is. Now, in math talk, that means evaluate. Hey, do not talk amongst yourselves. The word evaluate in a math problem means tell me what the actual exact answer is. 9 to the 1/2 power. I want you guys, we have to know how to evaluate this. So in other words, you have to be able to tell me what 9 to the 1/2 power is equal to, the exact number it's equal to. Now, if you think the answer is 4.5, that's not what this problem is asking. This problem is not saying what is half of 9. This problem is saying what is 9 to the exponent of a half. And I know what you're thinking. You should be thinking this. Mr. Trutna, I have never ever done a fraction for an exponent before. There's never been a teacher who's asked me to do this before in my life, so how the heck would I know how to do it? Well, are you guys thinking that right now? You should be.
Yes.
Here's how you do it. Watch this. You know how to do it. You just don't know the process.
Do you write this down?
Write this down. Here's what you do. Guys, gals, you change it into a radical. Okay? So you change this into a radical just like we were working on. So you draw the radical. What's the index? 2. I'm not going to write the index. What would I put inside for the radicand?
Nothing.
No, I'd have to put something.
Oh, right. 9.
It's a 9. And actually, is it to the power of 1?
Yes.
Do I have to write the 1? Okay. Somebody in this class knows what the square root of 9 is.
It's 3.
3.
We just evaluated it.
Got him.
It's equal to 3.
That was on me.
9 to the 1/2 power, you guys, is equal to 3. Okay? Number 2. Oh, by the way, if you don't know why it's 3, it's because 3 times itself 2 times is equal to 9. 3 times 3 is 9. That's why the answer was 3. Okay? Number 2. 64 to the 1/3 power. Now, I want to evaluate this. So in other words, I want to know what is the exact answer to that problem.
I don't know.
And now you guys, if you think the answer is, like, if you think what I'm asking is, what is 1/3 of 64, that's not what I'm asking. Watch how we do this. I change it. My first step is, I change it into radical form. Okay? What's the index? 3. So put a 3 for the index. You guys, what's the radicand? 64. Now, the answer is, since the index is 3, you have to find a number that multiplies it by itself 3 times to make 64. So can anybody think of a number times itself 3 times that actually equals 64? 4 times 4 times 4. Guess what that equals?
64.
So 64 to the 1/3 power is equal to 4.
Got him.
All right?